Hey there, welcome to another Real Python video course. I'm going to be your instructor, Cesar Aguilar, and guide you through the very basics of Pandas and its main data structure called a data frame. What is Pandas? Pandas is a fast, powerful, and easy to use data analysis manipulation tool. No, really, what is Pandas? Pandas is just a Python module with extensive functionality for working with tabular data. And tabular data is all around us. You can get tabular data off the internet. Maybe somebody sends you a spreadsheet, or maybe you generate some report from a database. Maybe you've been using Python for some time now, and you're happy to stick with your spreadsheet application and wonder what the fuss is about with this Pandas library. So, why use Pandas? Well, let me give you a quick example here. Suppose your organization wants to fill a position for a Python developer. You did an initial screening of the candidates by giving them a Python test, and now you have a CSV file containing the Python scores. The CSV file contains in the first line the headers or the field names of the CSV data. You've got the name of the candidate, the city where they're from, their age, and then the score on the Python test. In addition, each row contains some sort of identifier that uniquely identifies each of the candidates. And what you'd like to do is pull out or extract from the CSV file all of the candidates that scored at least an 80 on the Python test. And you want to write those candidates in a new CSV file so you can go ahead and continue the hiring process with those candidates. Let's take a look then at what you'd write if you were to do this sort of manually in Python. As you can see, there's quite a bit of code. Let's go over the main idea. You're opening up a file that you're going to read that contains the job candidate's information, and then you're going to also open up a file with write mode that will be used to write all of the candidates that have at least a 80 score in the Python test. You can see that it's quite a bit of code to get something done that's fairly straightforward. And when you do create this file, you get the top candidates that had at least a Python score of 80. And you may have noticed that in the code, there wasn't anything done with, say, sorting the candidates, say, from highest Python score to lowest Python score. We just looped through each of the candidates and then saved their information if their Python score was at least 80. Now let me show you how you would do this exact same thing using the Pandas module. So here it is. Here's the code that you would need if you were going to use the Pandas module to accomplish the exact same thing. Just a few lines of code where you're opening up the file, extracting only the candidates that have at least a score of 80, and then simply writing that information to a CSV file. And in fact, if you wanted to sort the candidates from highest Python score to lowest Python score, you would add one more function call using a method that we'll talk about called sort values. And then once you've done that, you'll go ahead and write to a CSV file. And in this case, we actually get a CSV file where the candidates are sorted from highest Python score to lowest Python score. Now, this is a tiny peek on what you can do in Pandas. I mean, if you're only working with basic CSV file and tabular data and just want to do basic analysis, already maybe you're tempted to go ahead and learn Pandas. Believe me, once you learn Pandas, you'll wonder why you never took the time to learn it earlier. Let's talk about what we'll do in this course. This is going to be an introduction to Pandas and its main data structure, the data frame. The course assumes no prior knowledge of Pandas. We'll start at the very beginning. But of course, if you know a little bit of NumPy, that's a plus, but certainly not necessary. And the only real thing that you actually need for NumPy is knowing that you can do fancy indexing and that you can perform operations on columns instead of just individual cells. I'm going to be using the Jupyter Notebook in this course. And so if you know the basics of Jupyter, then that's a plus, but certainly not necessary. And if you've never used it before, after this course, you'll know all the very basic functionality in a Jupyter Notebook. Here's a broad overview of what we'll do in this course. Of course, we'll talk about the Pandas DataFrame, how to create one, and what are its basic attributes and methods. We'll talk about how to access, modify, add, sort, filter, and delete data in a data frame. We'll talk about how do we handle missing values. With real world applications, a lot of times the data comes in and some of the data is missing. One of the main reasons why Pandas was created was to create a flexible tool to perform quantitative analysis on financial data. And so we'll certainly talk about time series data. And then we'll briefly touch on some quick ways that you can visualize data. All right, so I've given you only a little taste of what Pandas is about, but hopefully you have enough motivation to want to learn this awesome tool and work with tabular data in ways that you didn't think was possible. Before we get going, I want to make sure that you've got your environment set up. I highly recommend using the Anaconda Python distribution. Head on over to anaconda.com and go to the product's individual version. The individual version is an open source distribution that comes installed with NumPy, Pandas, SciPy, Matplotlib, and many other data science modules in Python. It also comes installed with the Jupyter Notebook and the Jupyter Lab and the very nice editor called Spider. So if you head on over to anaconda.com, go on to the product's individual edition version, and then scroll down a bit and click on the download button, and then download the graphical installer for your operating system, either Windows, Mac OS, or Linux. I recommend the 64-bit graphical installer. Once the download is complete and you run the installation file, it's a pretty straightforward installation process. Once the installation is done, you'll have a navigator called Anaconda installed in your applications folder or your programs folder. And this is a dashboard containing links to open up all the different applications that come with Anaconda. You'll have Jupyter Lab, which is the newer version of the Jupyter Notebook, and then the classical Jupyter Notebook app. You'll have Spider. So go ahead and open either Jupyter Notebook or Jupyter Lab, whichever one you're more comfortable with. Once Jupyter launches, go ahead and create a new notebook using Python 3. And then from this point, you're all set to go. Let me show you another way to get going in this course if you don't want to use Anaconda. Another way is to use a virtual environment, which is essentially a standalone Python installation in a specified folder. Now, in order to do this, you need to use the VNV module. And so by typing into the console, whether you're using a Windows or a Mac machine or a Linux machine, use your current Python program. In this case, I'd be using Python 3 and then using the virtual environment or VNV module. And then what this first command will do is in your working directory, which you could go ahead and create a separate folder for this course. And then within that folder, run this first command, and this will create a new folder called VNV. And within this folder, what this first command will do is install a standalone Python installation. Now, this is a good thing to do in general so that you can install whatever modules you want, and all of those modules will be installed in this folder, and then you won't have any conflicts with other versions of those same modules that maybe say you need for a different project, or if you're just experimenting with different versions. So this first line, once you've done that, you then need to activate that Python installation. And so you would source that, and then you navigate using this second line here to the activate script that's contained inside the bin subdirectory of that VNV folder that you just created. And then you need to install the modules. So for this course, you're going to need the NumPy module, the Matplotlib module, of course, Pandas, and Jupyter, if you're going to be using Jupyter for the course. And so to install those modules, you can use pip3 install and then pass in the requirements.txt file. And so what this file will be is just you can list the name of these modules, one on each line. And so that will allow you to install all of them at once. And then once that's downloaded and installed, you can then just open up a Jupyter Notebook by typing in Jupyter Space Notebook, and that will fire up a Jupyter server. And I'll show you how to do that. But once you're all done and you've closed up your Jupyter tab and want to close down the browser, and you've done that as well, then you can deactivate the virtual environment that you activated up here, and that will take you back to the system Python that you had installed as your default Python version. So let me show you how to do that real quick in the shell. In your home directory or whatever directory that you'd like, go ahead and create a folder for this course. I created one in my home folder, and I've called this folder the Pandas _DataFrame folder. Let's create the virtual environment. So go ahead and type Python 3, and then we're going to be using the M flag, which specifies the module, and the module is VNV, and we want to create in this current working directory a folder also called VNV. And when that's done, if you take a look at the contents of the directory, we have the requirements.txt file, but then more importantly, we've created this virtual environment subfolder. And let's take a look at the requirements file. So this is a basic text file that contains the name of the modules that you want to install. Let's clear that up. And so now we need to activate the virtual environment. So that's with source. In the current working directory, we've got the VNV subdirectory that we just created. And then within that, we've got the bin directory and then the activate script. So run that, and then you'll see that you've also got some indication that you're working now with a Python installation in this virtual environment. Now you want to use pip to install the modules contained in the requirements text file. And so this is the part that might take a bit because it's going to require the modules to be downloaded and installed. And this might take a couple minutes depending on your computer and your internet connection. So this starts to download all the modules that are needed. All right, and so once that is done, you could say clear things up, and then if you type Jupyter Notebook and run that, you'll get a Jupyter server running, and it will start in the folder where you executed that command, which again was our working directory that contained the virtual environment subfolder and then the requirements.txt file. And then as before, you can open up a new Jupyter Notebook with Python 3, and then you'll be ready to go just like before. In this lesson, we'll do a quick overview of creating a Pandas data frame and how to access rows and columns in the data frame. A data frame is a data structure used to represent tabular data. A data frame is going to be one of the main data structures that you're going to be working with in Pandas. As a running example that we'll use in this video course, we're going to use this table that contains information about job candidates for a position that we want to fill for a Python developer. This is the same tabular data that we used in the overview lesson. So we've got the name of the candidate, the city that they're from, their age, and then the score in their Python test. So at the very top, we've got what are called column labels or field labels. And then at the very left, we've got what are called the row labels or the index of the table. And then at the intersection of a row and a column, we've got a cell or the data. So let's head over to Jupyter and create our first data frame that will contain this three pieces of information: the row labels, the column labels, and the actual data. Back here in Jupyter, what we're going to do is first create a little bit of Markdown just as a way for us to create a notebook that will contain both titles and headings and information about what we're doing in the code, sort of as a way to provide comments as well. When you create a new Jupyter notebook, the type of cell that you're going to be presented with is a code cell to write Python code. So I'm going to convert to a Markdown cell. I'm going to hit Escape, and that takes me out from edit mode to command mode. And you notice that the cell became blue And then from here, I'm going to hit M, and that converts into a markdown cell. And either by pressing enter or moving the cursor to the cell, I can now write in my markdown. If you're not familiar with markdown, it's pretty straightforward. So let's suppose we wanted to make a heading. So I'm going to make a hash symbol, and then maybe we'll call this, say, introducing the Pandas DataFrame. And Shift Enter executes that cell and then gives you a new cell. And the default new cell is going to be a code cell. So let's go ahead and import Pandas. And the widely used alias for Pandas is PD. So let's go ahead and Shift Enter. Now, there are many ways to create a data frame in Pandas. We're going to use a dictionary, and the keys are going to serve as the column labels, and the values are going to serve as the data in each of the columns. So I'm going to copy paste the dictionary that I'm going to call data, which contains as the keys the names of the columns that I want to use. And then the values are going to be the data for that column. And you can go ahead and type this dictionary out, or you can just copy paste it from the data that accompanies the video course. I'm now going to create a list that will contain the index labels or the row labels for our data frame. And so I'm going to call this, say, index, and I'm going to use the numbers 101 to 102. And so maybe what I'll use instead is Python's range function, start at 101 and go to 107. So I'm going to go 108. So run those cells with Shift Enter. And then let's use the constructor for the data frame object. So we'll pass in the data, and then we'll specify the index for the rows. And so that is using the keyword argument index. And the index labels are stored in that index range object that we created, which could have been a list or a tuple. So let's run that, Shift Enter, and there we get a nice printout of the data frame. Now let's save this data frame in, say, the variable df, run that again, and let's take a look at the type of df. So we've got the Pandas module, and then we've got modules contained within Pandas, and then the final type is called the data frame. Now let's take a look at two important attributes of a data frame object. So these are the index, which in this case is a range index object, and it starts at 101 and it ends at 108 and the step of 1. So this is essentially like a range object that you're used to in Python. And then we've got the columns attribute, and this is a Pandas index object. And so if we take a look at the type, and so this is an index object in the Pandas module, which is also one of the main data structures in Pandas. There are two important methods on a data frame object, and these are the head and the tail. And you may be familiar with the two Unix bash commands with the same names, head and tail. And what they do is they print only the first 5 rows. That's for the head. And then for the tail, this returns the last 5 rows of the data frame. So this is useful, for example, when you've loaded up or you've created a data frame that contains many rows and you want to get a quick visual of the data frame. So a good thing to do is just take a look at the first 5 rows or so, or the last rows. And you can also pass in a value for how many rows you want to view. So for example, if we just want to view the first 3, we can pass in an argument of 3 and so on. All right, so there you go. You created your first Pandas data frame. You also took a look at a couple of important attributes, which are the index and the columns on a data frame, and a couple of useful methods called head and tail, which allow you to take a little peek in on the data frame either from the top rows or from the bottom rows. Let's continue with this introduction to Pandas by going over how you access individual rows and columns in a data frame. A frequent operation that you'll be doing on a data frame is to extract rows or columns. So let's start with accessing, say, a column. Let's access this city column. And so here you're going to be using notation that's similar to a Python dictionary. So in this case, you're going to access the column with the label city, and this will return a Pandas series object. And you can think of a Pandas series object as either an entire row or an entire column of a data frame. So if we check out the type of the city column, we get a Pandas series. Now let's save this column in the variable, say, cities. And if we take a look at this again, we see that we not only extracted the data in that column, we also extracted the index or the row labels. And so a Pandas series object will also contain an index attribute, which in this case will be the same as the index in the data frame because we extracted an entire column of the data frame. Another way that you can extract a column is to use dot notation. But this will only work if the name of the column that you want to extract is a string that's a valid Python identifier. So for example, if we wanted to extract, say, the age column, we would simply type .age. And then in this case, we get that series object. But if we tried this with the Python score column, so py-score, we're going to get an attribute error because Panda thinks that we are extracting the column that's called py, and we're subtracting it from some other series object called score. So if we wanted to extract that py score column, we'd have to use the bracket notation and simply write out the full column name. Now let's talk about extracting rows. So the rows, if you remember, they're labeled or they're found in the index attribute, and we know that these are 101 to 108, but not including 108, so the last one's 107. So to access a whole row, say with index value 103, we use the loc accessor method. So the way to do this is to call the data frame with loc and then bracket notation and then the actual label of the row that we want to access. So let's say 103. So this returns a Pandas series object as well. So let's see the data type for that just to make sure. And so we have a Pandas series. Now, if you recall, we also have the cities series and its index is the exact same. However, with series objects, contrary to when we were working with a data frame where we had to use the .loc accessor method, if we're working with a series object, we can directly access the index just using bracket notation like this. So that's one key difference between series objects and data frame objects. So if we go ahead and try that, we'll directly get the only value for that index, which is prog. Whereas when we use the index value on a data frame, we needed to use the .loc method. And we saw then, of course, that this returns a whole series object. Whereas if we're working with a series object and we use one of the values of the index to access a value, we're going to get a single value. All right, so with this lesson and the previous lesson, you got a broad overview of the Pandas module and some of the basics with creating a Pandas data frame and also working with some of the series objects that are built into a data frame. We also quickly went over how you access rows and columns in a data frame. And in the next lesson, what we'll do is we'll take a look at other ways to create a Pandas data frame.